Deep inside the Great Pyramid of Giza, in the red granite chamber known as the King's Chamber, sits an empty stone box. No lid, no inscription, no body. Just a massive granite sarcophagus, hollowed out and waiting. For centuries, Egyptologists debated what it was for, but acoustic researchers who studied it in recent decades found something the historians hadn't looked for. The box sings. When struck, the granite sarcophagus resonates between 114 and 122 hertz, a frequency range that aligns almost exactly with the intoning range of the adult male voice. Not approximately, not coincidentally close. The overlap is near perfect. The King's Chamber itself, 10.47 meters long, 5.23 meters wide, 5.81 meters tall, was found to produce a principal resonant frequency of around 117 hertz. Those numbers weren't arrived at randomly. To hit 117 hertz in stone, the dimensions of the room must be precisely coordinated. You don't stumble into that. You calculate it. But the resonance in the King's Chamber is only the beginning. Beneath the pyramid, carved into the bedrock far below the main structure, lies the subterranean chamber. Inside it, a feature known as the Dead End Passage, a shaft that leads nowhere, terminating in solid rock. Researchers found that this passage functions as an acoustic resonator, generating infrasound at approximately 5 hertz. Infrasound is not a sound you hear. It is a sound you feel. At 5 hertz, the human body responds without understanding why. A pressure building in the chest, a creeping sense of unease, a feeling that something in the room has shifted. Military researchers have deliberately used infrasound to induce panic and cognitive disruption. It affects vision. It can produce feelings of dread that arrive without any cause the victim can name. The people who built the Great Pyramid were working with hand tools and stone. They had no frequency analyzers, no acoustic modeling software, no formal equations of sound propagation. And yet the chambers they carved, both above ground and deep below, appear tuned. The King's Chamber dimensions converge on a specific resonant pitch. The dead-end passage generates a frequency below the threshold of hearing, but well within the threshold of feeling. There are 2 possible explanations. The first is coincidence, a multi-chamber cross-frequency coincidence that somehow aligned the acoustic properties of a sealed stone interior with both the intoning male voice and the outer edges of human sensory experience. The second is that the builders knew exactly what they were doing. If they did, what if these chambers were engineered to vibrate the human body rather than please the ears? Then what exactly were those chambers built to do? Off the coast of Sicily, on the small island of Malta, sits one of the oldest and strangest structures ever discovered. The Hypogeum of Hal Saflieni, carved from solid limestone sometime between 3600 and 2500 BCE, descends 3 levels underground, a labyrinth of chambers, passages, and niches, cut by hand into the rock. No one is entirely sure what it was for. A burial site, most archaeologists suggest. But there is one room inside it that complicates that explanation considerably. The oracle room. Stand inside it and speak normally. Your voice moves through the chamber and disperses. Nothing unusual, but pitch your voice at approximately 110 hertz, a low, resonant hum, and something changes entirely. The sound doesn't just travel. It fills the entire complex, every chamber, every passage, every hollow carved into the surrounding rock. And the people inside don't just hear it, they feel it. In the chest, behind the eyes, deep in the skull, in places sound doesn't normally reach. Researchers who've stood in that room describe it as deeply unsettling. Not unpleasant exactly, just wrong. As if the sound is coming from inside rather than outside. As if the room is producing the noise, not you. In 1994, a research consortium that included scholars affiliated with Princeton University conducted acoustic studies at megalithic sites across northern Europe. What they found was consistent enough to be troubling. At Newgrange in Ireland, at Wayland's Smithy in England, at multiple other ancient stone chambers spread across the continent. The same resonance profile kept appearing, standing waves sustaining in a frequency band between 90 and 120 hertz. The same narrow range, over and over again, carved into different stone in different countries, by people separated by centuries and geography. That overlap should not exist by accident. These cultures had no known contact. They shared no written language, no trade network that would transmit architectural theory, no common priest class shuttling between Ireland and Malta carrying blueprints. And yet the chambers they built, independently across thousands of miles and potentially thousands of years, converge on the same acoustic frequency range with a consistency that modern researchers still cannot fully explain. The 90 to 120 Hz band is not arbitrary. It is the range in which the human body stops being a passive receiver and starts being a resonant object. Bones, organs, and tissue vibrating in response to the room around them. So the question is not just why Malta's Oracle Room does this, the question is why they were all doing it, every one of them. Across a world that, by every measure of conventional history, should have had no idea the others existed. The same question dogs every ancient acoustic mystery we have. But there is one case where we actually found the answer. And finding it made things stranger, not clearer. In the 4th century BCE, on a hillside in northeastern Greece, an architect named Polykleitos the Younger designed a theater at the sanctuary of Epidaurus. The site was not built for entertainment. Epidaurus was a medical complex, a place where the sick came to be healed, where priests carried out ritual ceremonies dedicated to Asclepius, the god of medicine. The theater was part of that ritual. Sound was not an amenity, it was the mechanism. The theater seated approximately 14,000 people. And from the circular stone performance area at its center, unamplified speech, a normal speaking voice at normal volume, carried with total clarity to every seat in the structure. Not just the first few rows, every row, the back was as acoustically present as the front. No distortion, no echo. Words arrived perfectly intact at the uppermost tier, unchanged by the distance. The Greeks recognized that Epidaurus was exceptional. They tried to build something equivalent. Other theaters went up across the ancient world. Same proportions roughly, similar stone, similar shape. None matched it, not even close. The architects who attempted those replications had personally visited Epidaurus, walked its dimensions, studied its curves. They still couldn't do what it did. No surviving Greek source ever explained why it worked. They knew that it did. That was apparently enough. That explanation took roughly 2,500 years to arrive. Modern acoustic researchers eventually found it. The limestone seating at Epidaurus functions as a natural acoustic filter. The rows of stone suppress low-frequency ambient noise, crowd murmur, shuffling, the background hum that degrades speech, while simultaneously reflecting high-frequency vocal components back toward every section of the audience. The specific angle of each row, the composition of the limestone, the radius of the seating arc, all of it combines to protect the signal while eliminating the noise. It operates passively with no moving parts, no adjustment, no mechanism of any kind. It is a passive acoustic filter built in the 4th century BCE by people who had no formal theory of sound propagation and nothing resembling modern acoustic science. They simply built it correctly, which raises a question that no one has yet satisfactorily answered. How do you engineer a precisely functional acoustic structure 2.5 millennia before the physics that explain it were ever written down? Epidaurus at least gives us an answer, even if that answer opens more questions. The next case gives us almost nothing, just a sound that shouldn't exist, coming from a pyramid that was supposedly built for watching a snake. El Castillo rises from the flat scrubland of Mexico's Yucatan Peninsula, a stepped pyramid at the heart of the ancient Mayan city of Chichen Itza. It is best known for a visual effect. At the spring and autumn equinoxes, the shadows cast by its stepped edges create the illusion of a serpent descending the northern staircase. Tourists gather for it. Photographs circulate every year. That phenomenon gets most of the attention. But there is something else El Castillo does that receives far less coverage, and it is considerably harder to explain. Stand near the base of the pyramid and clap your hands. What comes back is not a clap. It is a chirp. A descending pitch, falling off in frequency, fading like a bird call. Not the sharp percussive reflection you'd expect from a flat stone surface. Something else entirely. Something organic sounding. Something alive. In the late 1990s, acoustic engineer David Lubman began studying this effect systematically. What he found was that the stepped architecture of the pyramid functions as an acoustic diffraction grating. Each step, evenly spaced, consistent in height, acts as a separate reflective surface. When a broadband sound like a hand clap strikes the staircase, the different frequency components of that sound reflect back at slightly different times. The higher frequencies bounce back first, the lower ones follow, delayed by the geometry of the steps. The result is a frequency sweep, high to low, arriving in sequence, which the human ear perceives as a chirp. The effect is not limited to one side. All four faces of the pyramid produce it with the same descending character. The geometry is consistent enough that Lubman compared the acoustic signature to the call of the quetzal, a bird the Maya considered sacred. That comparison is where the question becomes genuinely difficult to dismiss. Because either the Mayan architects built a pyramid whose stepped geometry accidentally produced a sound indistinguishable from a sacred bird, consistently on all four sides at one of their most important religious sites, or they built it that way deliberately. And if they built it deliberately, they understood acoustic diffraction. They understood how stepped surfaces interact with broadband sound. They understood it well enough to engineer a specific result. They just never wrote down that they did. The Maya at least left us a pyramid. The builders at Chavin de Huantar left something harder to see, and harder to stand inside without feeling that something is profoundly wrong. Chavin de Huantar rises in a high valley of the Peruvian Andes, nearly 10,000 feet above sea level. It predates the Inca by more than 1,000 years. What its builders believed, how they organized themselves, what they were reaching for, most of it lost or contested. What survives is what lies underneath. Roughly half a mile of underground galleries, corridors, and chambers carved from stone, woven together by a network of ventilation ducts that thread through the structure's walls and floor. Archaeologists found instruments inside. Marine shell trumpets made from large conch shells sourced far outside the Andes were recovered in significant numbers. When researchers blew them underground, the sound that emerged wasn't music. It was a roar, low animal filling the space. The corridors scattered those echoes faster than the ear could track them. Off-carved stone walls through the duct network, bouncing back from multiple directions simultaneously. The roar appeared to have no single origin. It came from everywhere. From walls, from floors, from behind you when nothing stood there. But you don't need a trumpet to notice something is wrong. Researchers simply walking through the galleries while speaking to each other reported that their own voices changed as they moved. Not a subtle difference, not something you'd catch only on a recording. Something you notice mid-sentence. A quality in the sound of your own voice that feels off, displaced, like it's arriving from somewhere it shouldn't. One researcher described it plainly. You don't have to conduct an experiment. The space makes itself known. The ventilation ducts explain this. They aren't simple air channels. Their geometry, the angles at which they connect, the way they branch and loop back, manipulates how sound propagates through the complex. They extend reverberation. They displace echoes. A sound produced at one end of the system can arrive at another point from an unexpected direction, after an unexpected delay, at an unexpected volume. That is not an accident of construction. That is design. Whoever built Chavin de Huantar's underground network understood that sound could be used to alter perception. They engineered a space where your senses couldn't agree on where sound originated, where your own voice became unfamiliar, where the basic information your ears provided could no longer be trusted. That isn't accidental infrastructure. That is deliberate disorientation, built in stone, thousands of years before anyone had a name for what it was designed to do. What the Chavin builders did with corridors and ducts, the builders at Pumapunku did with the stone itself. Pumapunku sits on the Bolivian altiplano at nearly 12,800 feet above sea level, part of the broader Tiwanaku archaeological complex that remains one of South America's least understood ancient sites. It is best known for its stone cutting, H-shaped blocks machined to interlock with geometric tolerances that baffle engineers working with modern tools. That precision is genuinely difficult to explain on its own. But scattered among those blocks are objects that raise a different kind of question entirely. One that has nothing to do with how the stones were cut, and everything to do with what they were built to do. Certain blocks at Pumapunku contain carved cavities, hollow shapes cut into the rock with geometric precision. Not random voids or natural erosion. Deliberate recesses, shaped and smoothed, cut into hard andesite, one of the more unforgiving materials a stonecutter can work with. Strike one of these cavities with a rod, or draw air across its opening at the right angle, and the stone produces a sustained musical note. Pure, clean, lasting for minutes without significant decay. Not a thud, not a dull knock, not the flat percussion of struck rock. A tone. This is not a phenomenon unique to Pumapunku. Archaeologists working in ancient cave systems and megalithic sites around the world have documented what they call lithophones, naturally resonant stone formations or deliberately worked stones, engineered to ring like bells or gongs when struck. Some of the oldest cave paintings on record have been found on walls that also exhibit strong acoustic resonance. The act of marking stone and the act of making it sing may have been, for certain ancient cultures, inseparable. But what makes Pumapunku different is the precision of the carving and the hardness of the raw material. These are not natural resonating formations that someone discovered and used. Someone climbed to nearly 13,000 feet, quarried andesite, and spent extraordinary effort cutting cavities into it, with a geometry precise enough to produce a specific sustained tone. That requires knowledge of how cavity shape determines resonant frequency. It requires testing, refinement, intention. No musical notation survives, no instrument manual, no record of what these stones were meant to sound like together, what ceremony surrounded them, or who was permitted to play them. The stones remember the note. Everything else, the hands that shaped them, the purpose they served, the people who built instruments into a mountainside, is gone. Not every ancient sound device is a mystery of architecture or lost culture. Some have survived intact, passed down through generations, still in use today. And the more closely scientists have examined them, the stranger they have become. Himalayan singing bowls, often called Tibetan singing bowls, have been crafted in the same basic tradition since around 500 BCE. The construction process is precise. A brass alloy, sometimes incorporating several metals, hammered by hand into a hemispherical shell, then turned on a lathe until the walls reach near perfect symmetry. The resulting object looks simple. A bowl. Wide lip, curved base, unremarkable at a glance. The acoustic mechanism is straightforward enough. Strike the rim with a mallet or drag a wooden rod around the outer edge, and a friction sets the walls vibrating. The bowl resonates. Sound emerges. This is the same basic principle behind any struck or bowed instrument. Nothing that requires unusual explanation, but then you add water. Fill a singing bowl partially with water, set it vibrating, and the surface responds. Waves form, driven by the vibration in the walls. As the amplitude increases, as the bowl is played harder, the vibration intensifying, something documented, filmed, and confirmed by modern physics researchers begins to happen. Water droplets bounce on the surface of those waves. At sufficient amplitude, they levitate. They lift off the surface and hang suspended above the water, held aloft by the acoustic pressure of the waves beneath them. This is not legend or mystical claim. It has been captured on high-speed camera. It is reproducible. It is real. What the original Tibetan craftsmen understood about this effect is entirely unknown. There is no surviving text that describes it, no ritual document explaining that the bowl was built to levitate water. But the construction precision required to produce consistent acoustic behavior suggests the object was engineered carefully, not stumbled upon. The alloy composition matters. The wall thickness matters. The symmetry of the lip matters. The acoustic output of these bowls is also far more complex than it appears. A single bowl produces multiple simultaneous frequencies, layered overtones that shift depending on where it is struck, how fast the rod moves, and the pressure applied. Scientists studying their full acoustic profile still argue about how to characterize it. The sound is not one thing. It is several things at once, interacting. So, step back from the physics for a moment. Somewhere around 500 BCE, someone designed an object from metal that could generate layered simultaneous frequencies, produce reproducible resonance effects, and use sound waves to overcome gravity. Why? What were they trying to do with that? Most people know Stonehenge as an astronomical instrument. The alignment with the summer solstice sunrise is well documented, studied, measured, written about extensively. That part of the story is considered settled, and it tends to be where the conversation ends. What is far less discussed and considerably more disorienting to consider is what Stonehenge sounded like when it was complete. What stands on Salisbury Plain today is a ruin. The outer sarsen ring is partially intact. The bluestones that once filled the interior are mostly gone, scattered, toppled, vanished over centuries. What visitors walk through now is a fragment, and a fragment tells you very little about how the whole thing behaved acoustically. Researchers who ran modern acoustic simulations of Stonehenge in its complete form found something the ruins don't reveal. When the interior configuration was intact, the full arrangement of bluestones, uprights, and lintels filling the enclosed space, sound entering the structure from any source would scatter off multiple surfaces before reaching the perimeter. Not a clean reflection, not a distinct echo arriving from one direction, a cascade of overlapping returns, arriving from everywhere with no identifiable point of origin. To test this, acoustic researchers built a scaled replica designed to reproduce the original configuration and produce sounds inside it. The result was consistent and strange. Voices seemed omnidirectional. No single source. Sound arrived as if it were being generated by the space itself rather than by any person within it. You couldn't locate the speaker, you couldn't locate yourself. At low frequencies, the complete structure would have supported standing wave formation, self-reinforcing patterns of sound that fill an enclosed space and don't decay at the normal rate. The same phenomenon confirmed at Newgrange, the same frequency range implicated at Malta. A stable field of sound inside a stone enclosure felt as much as heard. Stonehenge's solar alignments required centuries of careful observation, precise planning, and the movement of stones weighing dozens of tons across hundreds of miles. That effort is well understood and widely celebrated, but the acoustic properties of the structure required the same deliberate geometric arrangement of the same stones. Both effects were built into a single site. They were not building an observatory with an incidental echo. They were building a room with a specific engineered sound, one in which any voice became sourceless, any speaker became invisible, and anyone standing inside could no longer trust their own senses about where that sound was coming from. That's not a side effect. That's a design goal. Stonehenge was built around 3000 BCE, the Great Pyramid of Giza around 2560 BCE. Both are ancient enough that their construction methods remain contested and their original purposes still debated. Newgrange predates both of them. The passage mound at Newgrange in Ireland was constructed approximately 5,200 years ago, deep in the Neolithic, before bronze, before writing, before any civilization we would recognize as a precursor to our own. Its builders are nameless, their language is unknown, their beliefs survive only as stone. Newgrange is famous for one reason above all others. Once a year at winter solstice dawn, a shaft of sunlight enters a narrow opening above the passage entrance and travels 19 meters into the earth, illuminating the inner chamber for approximately 17 minutes before withdrawing. The precision required to achieve this, the orientation of the passage, the height of the opening, the alignment of the walls, is extraordinary for any period of human construction. For 3200 BCE, it is almost incomprehensible. That is the story most people know. It tends to be where the story stops. But archaeoacoustic researchers who studied Newgrange's inner chamber found that the solar alignment is only half of what the structure does. When low-frequency sound is produced inside the chamber, a sustained hum, a drum, a voice held at the right pitch, a standing wave forms. A stable, self-reinforcing acoustic pattern that fills the enclosed space and resists decay at a rate that ordinary sound in ordinary rooms does not. The sound doesn't just linger, it locks in. It becomes the room. The frequency range in which this occurs falls between 90 and 120 Hz. The same range confirmed at Malta's Hypogeum. The same range documented at Wayland's Smithy and Newgrange's neighboring megalithic sites. The chamber dimensions at Newgrange are not random. They are calibrated, whether intentionally or through accumulated acoustic knowledge passed through generations of builders, to sustain that specific phenomenon. So the chamber catches light once a year at a precise astronomical moment, and it holds sound at a frequency that resonates in human bone and tissue in a way that doesn't dissipate the way sound normally should. Two engineered phenomena. One stone chamber, built by people with no written language and no tools beyond what they could make by hand. Neither of these effects is accidental. You cannot accidentally calibrate both the optics and the acoustics of a structure. You cannot stumble into this twice in the same room. separated by thousands of years of subsequent ignorance about how you did it. Someone knew exactly what they were building. Those builders, whoever they were, clearly understood something about sound that we are still piecing back together. But there is one question that haunts every site in this list, and it is the oldest and strangest one of all. How did they move the stones? In the 10th century, the Arab historian al-Masudi wrote about ancient Egyptian construction methods that most scholars have been reluctant to take seriously. He described a process in which inscribed papyrus was placed beneath each stone before a metal rod was struck against it. The stone then lifted. It was guided along a path flanked by metal poles on either side until it reached its final destination. Al-Masudi was recording accounts he believed to be historical. Modern historians generally file them as myth and move on, but a pattern keeps emerging that makes that dismissal harder to sustain. In almost every civilization where enormous stone monuments exist, a tradition also exists claiming those stones were moved through sound. Not machinery, not ramps. Sound. Chanting, singing, striking rods, blowing instruments. Egyptian accounts describe resonant striking and metal poles. British folklore references the singing of stones into place. Mesoamerican accounts involve instruments played at construction sites. These traditions come from cultures separated by oceans and thousands of years with no known contact between them. In 1939, a physician named Jarl reported witnessing Tibetan monks arrange 13 drums and 6 trumpets in a 90-degree arc around a large, heavy stone and play in unison, chanting simultaneously. After several minutes, the stone lifted and traveled upward approximately 250 meters to a ledge above. Jarl claimed to have filmed it. Whether that footage still exists is disputed. His written account is on record. Acoustic levitation is not a fringe claim. Modern laboratory experiments have suspended water droplets, particles, and small solid objects in midair using focused sound waves. The physics are confirmed and reproducible. At the scale of multi-ton stone blocks, those same physics become implausible. The energy requirements would be catastrophic, the required wavelengths unworkable. And yet, Egypt, Tibet, Britain, the Americas. The same story told independently across the entire ancient world. What did these civilizations believe sound was capable of? And is there something embedded in that shared conviction? Something beneath the legend itself? That we simply do not yet have the physics to explain? Because that question has never been properly answered. It has only ever been dismissed. Step back from the individual sites for a moment and look at what they share. The Great Pyramid's king's chamber tuned to the male intoning voice. Malta's oracle room sustaining resonance felt in bone rather than heard by ear. Newgrange holding a standing wave at the same frequency range, inside a chamber also calibrated to catch a single shaft of winter solstice light. Chavin de Wantar's corridors engineered to make your own voice unrecognizable. Stonehenge arranged to render any speaker sourceless and omnidirectional. Epidaurus filtering noise and amplifying speech with passive geometry its own builders couldn't explain. These are not coincidences scattered randomly across the archaeological record. They are a pattern. A consistent, deliberate, cross-cultural engagement with sound as a technology, pursued with measurable precision by civilizations that shared no language, no trade routes, no known communication of any kind. The 90 to 120 Hz frequency range alone should force a reckoning. It appears at Malta, at Newgrange, at Wayland's Smithy, at multiple other megalithic sites on multiple continents. That range is not acoustically inevitable. It does not emerge automatically from any arrangement of stone. It has to be built in. And it keeps appearing independently in structures separated by thousands of miles and in some cases, thousands of years. Modern archaeoacoustics is a young field. Researchers are only now developing measurement tools sophisticated enough to characterize what these ancient builders accomplished. The discipline barely existed 30 years ago, which means that for most of recorded history, these acoustic properties were simply present, unexamined, attributed to nothing. But here's what every entry in this list has in common. Beyond the frequencies and the engineering, no manual survives, no treatise, no theoretical document explaining the principles behind any of it. The builders of Newgrange left no text describing why the chamber dimensions produce a standing wave. Polyclitus the Younger left no notes on acoustic filtering. The architects of Chavin left no blueprint for disorientation through duct geometry. They built to the effect. They knew what they wanted the space to do, and they built it until it did that. The underlying theory, why these frequencies, why these dimensions, what precisely was being achieved and for whom, was either never written, deliberately withheld, or lost so completely that no trace remains. We are now using the most advanced acoustic measurement technology ever developed to rediscover what someone carved into limestone 4,000 years ago. That should be humbling, and it raises a question with no clean answer. If this much was lost, what else are we still missing?